All right, take a look at this one. It says find the length. And again, I want to kind of start to use some underlining here. It says find the length, finding being the verb. Find the length of right rectangular prism, having the measurements listed below. Volume equals 17 and 986 thousandth cubic inches. Width is 4 and 6/10 inches. Height is 1 and 7/10 inches. Let's see here. Natalie Baker, can you just tell me the formula for volume of a right rectangular prism? Like, what's the formula? No numbers, just what's the formula? All right, so we have volume equals length times width times height. And sometimes I think you like to use that cursive L because if it's a number 1, it's kind of hard to tell the difference between a number 1 and just a regular hand-printed L. So that's why I use a cursive there. Now, it looks like they've given me some things. So I can use, what do we use that, when we take something and replace it? What do you call that? When we replace it with something, starts a big word starts with S. Melgoza, how goes it? Substitution. So Melgoza, we could substitute this V for what? There you go. So we'll take out that V and substitute with 17 and 986 thousandths. And then right after that comes equals. Do I need to have these in this order? No, because it's multiplication. That is commutative. So Marsicki, we're going to put this L at the back because I need to know the length. So with that fancy hair over there, Marsicki, could you tell me what could I substitute next? The W. And what is the W? There we go, kid. And we're going to multiply this, so I'll put a little multiplication sign. Jillian, what would come next? We've used the L, we've used the W, we've replaced the V. We only have the H. What do you have to do there? 1 and 7/10. Nice. So 1 and 7/10. Okay, now we have a nice algebraic equation here. We have an equal sign, we have an operation on the right-hand side, we have a little variable over there. What would I need to do first here to help me begin to solve this equation? What would I need to do first? And I actually saw a couple of you walked around already doing that, which is great to see. Skiles. What would I need to multiply? There's 3 numbers there, bud. 4 and 6/10, yes. And there we go. So I'm going to multiply these 2 out. And I can't do that in my head, so I'm going to come over here. I am going to think about estimating, though. 4 could probably round up to 5. 1 and 7/10 could probably round out to 2. So 5 times 2 is about what? So I know when I multiply these out, I should get a ballpark of around 10. So we go 6 times 7 is 42. 7 times 4 is 28 plus 4 gives me what, 32? Okay, done with that 7. I'm going to cross out, put a 0 here, place value. 1 times 6 is 6. 1 times 4 is 4, I believe. If I add that, I get 2, 8, 7. I have 1 decimal place here, 1 decimal place here, so I move it over twice. Get an answer of 7 and 82/100. Now, that's about 8. My estimate was 10. I'm happy with that. That's in the general vicinity. So now we've kind of condensed things, simplified a little bit. So now we have 7 and 82/100 times L. Marcuzzo, what do I do next, bud? Yeah, I like, but what am I dividing both sides by? It's important. 82/100. There we go. And I like that you started with that, 7 and 82/100. I'm glad you didn't say 7.82. Now this is a little bit of an ugly division problem. Ugly like me looking in the mirror in the morning, ugly. That's not funny. Now, we have 2 decimal points in my divisor, so we must move it over 2. If I move it over 2 here, I also have to move it 2 in my what? Dividend. So we move it over 2 here. So this really becomes 1,798 and 6/10 divided by 782. Yuck. First thing I'm going to do is I'm going to put a decimal up in my quotient. Will 782 go into 1? Will it go into 17? Will it go into 179? Will it go into 1,798? Yes. Now, my thought is, let's look at the 7. Let's look at the 1 and the 7 here. How many times will 7 go into 17? Twice. I like it so far. 2 times 2 is 4. Must make sure I line things up. 2 times 8 is 16. I have a little 1 to carry over, so 2 times 7 is Hess what? What's 2 times 7? Yep, just like in North Carolina. Plus 1 is what? That girl. 15. All right. Now we are going to subtract. Oh, this is nice. No regrouping. 4, 3, 2, and bring down a 6. Just like I did last time. Now I'm going to focus on the 23 and the 7. How many times will 7 go into 23? How many 7s go into 23? Yes, Mr. Lucas. 3. Let's take a look, Lucas. Lucas, what's 7 times 2? Or excuse me, 3 times 2. My fault, bud. No, my fault. I said the wrong numbers. 3 times 2 is 6. 3 times 8, 24. With the 2 now up here. And then we have 7 times 3 is, plus the 2 we have. And I like this because there's nothing left over. Now, we are looking for the length. How would I label this answer? We have 2 3/10. I can even say I should probably do this. L is equal to 2 3/10. But how would I label this answer? Be careful with how you respond to this. We gave you the volume. We gave you the width. We gave you the height. If I put 2 3/10 tomorrow, I've done all this great work. But you know what? If I don't have a label, I lose like a quarter of a point. I don't want to lose a quarter of a point. Baker's dozen. What do I have? Inches. Inches. Just inches. Just inches, right? Because we're not finding area, so we just got inches. All right? And we are done. There is my final answer. Is that a lot of multiplication and division? Yes, absolutely. All right.